Hey, 12th video today, solving simultaneous equations. Okay, we have essentially been doing this graphically until now. We're going to do it algebraically or analytically now. Okay, so we're not going to draw those graphs. We're not going to rely on having drawn those really neatly and reading it really carefully. Right, we're going to establish the solution to these pair of equations purely by using algebra. Now, notice what it says here. Commentary is essential, right? You have to explain what you're doing as you go through this. Right, let's see how that works. There are two general methods for doing this. One is substitution, the other is elimination. Right? Substituting means making one of those variables the subject of one of the equations and then replacing that variable in the other equation. I'll show you how this works. So, we have two equations here, 2x plus y equals 12 and y equals 5x minus 2. Notice here that y is the subject of this equation. So that means that any time I have a y, I could say 5x minus 2 instead, because they are equal, they are the same thing. The advantage of doing that is then I will only have one variable in that equation, and I will have enough information to solve that. Right, so when we talk about commentary, this is what it looks like. I need to refer to these equations. So I've got equations 1 and 2. And I'm going to say substitute sub 2 into 1. Right, I'm going to take equation 2 and I'm going to substitute that into equation 1. That looks like this. Therefore, 2x plus, instead of saying y, we say 5x minus 2 equals 12. And that's pretty solvable. Okay, that means that 7x minus 2 equals 12. 7x, add 2 to both sides, equals 14. We know x equals 2. Not finished. Okay, x equals 2, that's fine. I'm only halfway there. I need to find what y equals as well. Now I'm going to call this one 3 and sub 3 into, you can substitute into either of them. It's going to work nicely into 2 because y is the subject. It's like a formula now. So y equals not 5x but 5 times 2 minus 2. So y equals 10 minus 2 equals 8. That's my solution. Right, so my solution is 2, 8. If I substitute those points into either of these equations, right, I will get a I'll get an equivalent statement. The left-hand side will equal the right-hand side. Let's try that again here. A pair of equations, two variables, they're solvable. Right, they're not the same equations. I don't have either of those variables expressed as the subject, but what I'm going to do is I'm going to rewrite this one here. I'm going to say, therefore, A equals 2 plus 3B. Right, I've added 3B to both sides. I'm going to call that equation 1, that equation 2. Now that I have A expressed in this way, I can substitute into that. Sub 2 into 1. And I end up with, instead of saying A, I say 2 plus 3B. Whoops. So instead of A, I say 2 plus 3B, and I've got my plus 2B equals 7, right? Everything else remains the same. Instead of saying A, I'm taking the other side of that equation. Right, this is pretty solvable as well. I get 5B plus 2 equals 7, therefore 5B equals 5, B equals 1. Not finished yet. Let's call that 3. We're going to substitute 3 into, doesn't matter. Let's substitute into 2 because we've made A the subject of that and it'll work out pretty neatly. Therefore A equals 2 plus, instead of 3B I say 3 times 1 because I found out B equals 1. Therefore A equals 5. Okay, so my solution is A equals 5, b equals 1. I wrote it as a coordinates up here. It's not an xy pair now. I'm probably better off putting it like this. You can draw a little box around it or something. Don't make it hard to read. Just make it easy to find that answer. Okay, that's the substitution method. Work through that. Make sure you follow all the steps. Ask me some questions. Okay.